going to record this session. So any audio as well as video will be recorded. So the first technical working group for the City of White Rock Aquifer Protection Plan. The agenda for today's meeting is to do some brief introductions of who's online. I'm going to go through a quick one-way moment. We'll talk about the objectives, and then I'll pass it over to my colleague Zidra, who will be going through the background and methodology, and Matt Webb will be discussing some of the preliminary results. And the next step. And that said, if you have questions throughout, do feel free to ask. If it's more appropriate, hold on until the end. We're hoping to have some time at the end to go through things, and there's a lot of information here to cover. Working group invitations were sent to the following people. They recognize as people that may be good to include for regional discussions of the use for the Seaside Aquifer, which is the aquifer that the City of White Rock currently uses as their water supply. That's why these individuals were particularly identified, and all were requested to attend. Some can only attend the second webinar, and we'll be looking forward to seeing this recording. Others we didn't receive a response from. So just for record on the recording, the attendees today include Thad Dazim, Margaret Scott, Zidra Hammond, Matt Webb, Jefferson, Mark Bill, Mike Simpson. Okay. Is there anyone else in any of the other offices that is online listening in? Thank you. So, one-way moment. Advisian is the company that myself and Zidra and Matt work with. We're the overall Worley Parsons company. We were hired by the City of White Rock to help develop this draft aquifer protection plan. The Advisian under Parsons has a vision in general for zero harm to people, assets, and no environmental incidents. It kind of underpins all our activities that we do as a business, and one way that we highlight our commitment to health and safety and environmental assets is through our one-way enterprise-wide integrity management framework. And as a rule of thumb for any presentations that we do, we take a moment to think about aspects of health, safety, and environment, and how to improve the work that we do. Taking this one-way moment to talk about teamwork and how teamwork working together can help make great projects. So these are of the integrity management framework. This particular item talks to leadership and governance, and with our customers. Okay. So why fail? For the most part, a lot comes back to the plan, and that there's a failure to plan effectively. A nation of complexity of the work, and reason, failure to prioritize requirements, and failure to think ahead and address potential problems. There's a delay, changing slide. There we go. Themes, when we think about what causes failures in is typically lack of engagement, lack of engagement with the team, and issues with communication. Also related to the lack of trust, but I think communication is being key, and that's something I want to emphasize for this technical working group. This is our first chance to start the dialogue between regional water users of the Sunnyside Aquifer. Work makes work. We can get when we communicate effectively, when we have construction criticism, and when we speak up and comment and take accountability for the work that's being done, and we support each other. For this presentation. Now let's get into the juice of the meeting. The first webinar here really is to inform the technical working group of the project progress to date, highlight the work that's been done, discussing some of the data that's been collecting and how it's been compiled to develop the conceptual site model, and will help us also through discussion if you identify some data. Also collect feedback from yourselves as how we can make improvements to the current visualization and thoughts for the future work that's going to be done, and overall support the development of the draft Aquifer Protection Plan prior to presenting it at the public open house. So presentation to my colleague Phaedra, and she's going to start walking through some of the background details and the data that has been collected to develop the site model.
Okay, thanks, Margaret. Also with a background, not so much on the project, but more on the water supply system. So this Aquifer Protection Plan is being prepared for the White Rock water supply system. And the system currently uses groundwater from the Sunnyside Aquifer, as Margot mentioned previously. It services approximately 20,000 people, and that includes a small portion of Surrey and the Yamu First Nation. And historically, the system was operated by Aquifer, and the city purchased the system in 2015 and has been responsible for the day-to-day operations now. It's showing the location of the wells. So there are 7 active wells, and they are located at the High Street site, the Oxford site, and the Merkland site. The Buena Avenue site includes 5, but this well was taken offline in the beginning of the year, and it has been replaced with well 8 at the Oxford site. So I just want to on water consumption. So the system in 2015 and 2016 used approximately 2.4 to 2.3 million cubic meters of water. And the way groundwater was extracted from the network is shown visually on the pie graph here. And this piece that has been removed from the pie graph is the portion contributed by well number 5, which has been taken offline. And generally, the use of the other wells varies. The lowest use comes from well number 4 at less than 5%, and this well is used more to meet season peak demand. Groundwater quality. So groundwater extracted from the system has naturally occurring manganese and arsenic concentrations that are above or near drinking water guidelines. I'll speak a bit more about manganese and arsenic in the slides coming up. But there was also some E. coli contamination in 2010, and this was isolated to groundwater in 2 reservoirs at the Merkland Street site. That resulted in a 12-day waterborne advisory. With chloride and sodium concerns, given that the Sunnyside Aquifer is a coastal aquifer. So these concentrations in the wells is shown on this chart. So we have total manganese, and here we have the date where groundwaters were collected at each well. And this red dashed line shows the drinking water guideline, which for manganese is an aesthetic objective set at 0.05. So the concentrations vary depending on the well. Next slide, arsenic. We have arsenic concentrations, and for arsenic, the maximum allowable concentration of 0.01 is the drinking water guideline. And from this graph, we see that the 2 wells at the Merkland site, well number 6 and well number 7, are the closest to the drinking water guideline. And for this graph in the upper right-hand corner, we plot the relationship of well screen depth versus the concentration, the median concentration of arsenic. And we see generally it appears that the deeper wells tend to have a higher concentration of arsenic, and this could also be attributed to the material that the screens are instrumented with or nearby. In some regional context, the elevated arsenic is not just a problem for the city of White Rock. There have been elevated concentrations within the Fraser lowlands. Lowlands are known to exist. There has a study published by UBC in 2008 to the Fraser Health Authority and the MOE regarding arsenic in groundwater in the Surrey and Langley area. So this is not just an isolated concern for the city of White Rock. So here, chloride concentrations, but now we've plotted them against the distance from the coastline. So we see that as the wells that are located further from the coastline have a lower concentration, which we would expect. So that's some background on the water supply system itself, and now get into more details about the project.
I want to interject quickly. Can everyone hear okay?
Yes.
Thank you.
Okay, project is, the primary purpose is to develop an aquifer protection plan. So what do we want to achieve? This some groundwater protection goals that have been established with the city of White Rock. And one primary thing that we would like to do is engage stakeholders to guide development of the plan, to increase the knowledge and understanding of the Sunnyside aquifer. We want to develop a plan to protect water quality and quantity, and then also have a sustainable approach to extract groundwater to meet future demands. Now that we have those goals, how are we going to achieve or reach those goals? So our approach includes 6 steps, primarily based on the Groundwater Protection Toolkit published by MOE, with some applications to meet the goals of the project. So this technical webinar will focus on the first 4 steps. The 5th and the 6th step will be discussed in technical webinar 2. So I'll discuss step 1 to 4 in more detail in the preceding slides, and webinar 2 will discuss the predictive modeling results and then the management measures for discussion. Project includes the aquifer protection plan itself. So this will provide some characterization of the aquifer and also some management measures to protect groundwater resource and some strategies to help with that. The outcomes also include stakeholder engagement. So developing of this technical working group is an important step to starting discussion and the dialogue to protect groundwater in the area, because this is more than just a concern for the White Rock. We'll also provide some communications to the technical working group and the public that will hopefully help them to participate in development of the plan. The third project outcome includes development of a conceptual site model, which is important as it forms the basis for the groundwater model, and that can be used as an analysis tool for groundwater management. So those are 3 major outcomes of the project. The study we've used, and now this is mostly for data gathering, not necessarily the model boundary, but for data gathering purposes, we've established a study area that extends outside of the municipal boundary of White Rock, shown here in purple. And so the study includes the South Surrey upland, as well as the Nickel Serpentine lowlands and the Campbell lowlands. The study area also extends beyond the mapped aquifer boundary that has been completed by the MOE, and that's more to provide context on how this aquifer, the relationship between that aquifer and the surrounding aquifers. We have another slide that shows the extent of that, but to provide a rationale for the study area. I'll discuss the preliminary results. So that includes the first 4 tasks, just in our approach, so stakeholder engagement, data gathering, conceptual site model development, and potential contaminants. Engagement. Project website has been set up by the City of White Rock, and this will be used to communicate project-related material, including a recording of this webinar. We also be 2 technical working group webinars, which hopefully we can complete at the end of the year. There will be a open house scheduled early 2018, and also the DN and the City of White Rock will compile and track stakeholder comments. So the next involves data gathering, and this slide presents the water users that we've identified in the area. And this information is based on the wells database and also points of diversion or licensing information for the province. So here we see the majority of wells used in the area are for private domestic use. There are a few for irrigation and commercial, mostly along the eastern area, study area. We're particularly interested in water supply or wells used for water supply purposes, and so we have the wells with a network used by the City of White Rock. The two water supplies were also identified to the north, and we've confirmed with and these belong to the City of Surrey, and we've confirmed that they are used for water supply. At the moment, the City of Surrey is interested in potentially using groundwater to augment their current water supply. An important aspect was understanding surface use due to the potential groundwater surface water interaction. So within the City of White Rock network, there aren't any surface water users in close proximity. Most of them are located on the northern part of the study area and then to the east. The study area in the context of the match aquifers by the MOE. So we have the Sunnyside Aquifer, and then we have several aquifers to the north and to the east. We needed to consider in developing the conceptual site model. So the geological setting of the study area was very important. The Razor Lowlands has a very complex geological history. There have been several major glaciations divided by non-glacial intervals. And so the layering of the material is very complex. And to guide the development of our conceptual site model, we've considered surficial geology mapping and studies on geology that have been published. And in particular, there were two locations within our study area that have stratigraphic or stratigraphy profiles that have been interpreted by others that we've used to inform development of our conceptual site model. There's only two here, and that was based on this reference by Armstrong in 1984. So we've these profiles and compare them to logs that we have in proximity, and we've compared them just to make sure we stay consistent with work that's been done previously and to build upon that. So the source of data includes monitoring data from the City of White Rock. In general, we have complete data sets for 5 wells, and that includes water level information, pumping data, and totalizer information. I don't have any information for well number 4, but again, this is a seasonal well, and the City of White Rock has recently installed monitoring equipment to better track the use of groundwater from that well. We don't have any information for well number 8, but that's because this well has just recently been commissioned. So that we've completed, we've used that to help develop our conceptual site model. So the conceptual site model is important because it forms the basis for our for the 3D numerical model. That includes understanding the underlying lithology and stratigraphy, understanding where we have groundwater coming into the system and leaving the system, also understanding water levels in the context of groundwater flow and where is it moving to. And so it was quite iterative. We looked at the geology, and then we refined geologic interpretation based on the water levels. Then there was further refinement once we construct our groundwater model based on the calibration results. I'll speak to a bit more when Matt presents the groundwater model. Looked at the geology in detail to help build the conceptual model, or at least the layering of the groundwater model, and looked at information from the wells database and included there are 631 wells within the study area, and approximately 550 have lithology information. And just to put more context, only 164 are located within the boundary of the Sunnyside Aquifer. So many of them are located on the eastern portion of our study area. These points were used to create 15 cross-sections to conceptualize the subsurface conditions. And wells located outside of these cross-sections were also considered if they had water level and yield information. Sections, the conceptualization, and through the model calibration, the conceptualization of the hydrostratigraphy is shown in these next two slides. So we have cross-sections along the lower portion of the study area running west-east, and then the second cross-section runs south-north. We basically conceptualized, or the hydrostratigraphic framework consists of main layers. And so this layer is a glacial marine aquitard. So shown here, it extends through most of the, or it covers most of the study area. And again, that's based on the mapping that was done. Below glacial marine, or the layer, we have this upper till. And upper till sometimes extends to the surface. We're on the Surficial mapping to identify where these the outcroppings of this till exist, primarily because it was quite difficult to distinguish the glacial marine and the upper till deposit in some areas, or I guess it was just difficult to do that, so relied on the Surficial geology mapping. Below we have an upper sand and gravel layer, which is, we interpret aquifer related to the quadra sands. Sands, we have a lower till unit that interpreted to be an aquitard. Within that, the till is not continuous, and we have these areas where we have material that is more permeable, which we've identified with this light green color. And so the areas we conceptualize as acting as windows where inflow from the surface can move more easily into the Sunnyside Aquifer, which is the bottom layer that is shown in this cross-section. The bottom layer, the bottom of our conservation does not include bedrock, just because in our study area we only had one well with bedrock, and that was located over 300 meters below ground surface. So for the purpose of this study, we've just the bottom, or the bottom layer coincides with the bottom of the Sunnyside Aquifer, and that's typically where we see glacial marine and till deposits. This is a cross-section that runs south to north, and I didn't mention it in the previous slide, but the cross-sections do connect the wells used by the city of White Rock. And you can see the 5 layers here that I discussed previously. I just want to highlight that, with wells data set, there was some inconsistency, and the quality of data was not reliable. For example, we have the Surrey well that is shown here, which, if we look at the raw lithology, which is in this profile, then there is no quadrasand unit. It's just shown as a clay material, but there was an adjacent water that had the quadrasand, or an upper sand layer. So I guess this just highlights, and in the previous slide, there's one, I don't know if I can go back here, but some cross-section, we have a water well record. The entire profile is logged as gravel. So, just to understand that there are some limitations with the wells data set and the quality of lithology. And this is primarily when drilling more wells, interested in where there is a water source and not necessarily in the lithology, as they don't have the equipment or the ability to log it very accurately. Now I'm going to go over to Matt, and he's going to provide a live demo of the model.
Thanks, Idra. Presenter, and then I can start.
I think I have, but let me
Okay.
just...
Yep.
Yep, okay.
Can you hear me now?
Yeah, thank you.
Great. Okay. So we'll talk now about how the conceptual site model has been implemented in the numerical groundwater model. What you can see on your screen right now, aerial view model in 3 dimensions. The blue line is corresponding to the City of White Rock boundary. The dots are the City of White Rock water supply wells, and the yellow dots were locations that we had static observed water levels. I'll move the you can then see the Surficial Geology, and this matches the one which you saw earlier on a slide that Zita presented, and it's on the Geological Survey of Canada's Surficial Geology mapping. The layer 2, this is the upper till aquitard. Go down, and this is the upper end aquifer, the quadricents. More, and this is the lower till, and this shows you the spatial footprint of these two with high permeability that Zebra described on the cross sections. And then go to the lowest slice, and this is the Sunnyside aquifer. Okay, I'll go to slide. I'll show you the mesh that we have for the numerical model. Got about 125,000 nodes spread over 5 layers. The mesh spacing is approximately 50 meters uniformly throughout the domain. How you can see these locations here, the City of White Rock pumping wells, which we find the down to about half a meter. If I give you, I can view the boundary conditions that we have for the model. Let's lay this back. So hydraulic boundary conditions on the south and western correspond to the Semiami Bay and Bayou Bay. And but I'll turn the model around. You'll see areas appear. So this blue area on the southeast corresponds to the Cable River. And these blue areas on the eastern side, these represent inflow from the east. The reason for this is that the first iteration of the model during calibration indicated there was likely some additional inflow that had not been accounted for. So a second iteration of the conceptual site model was conducted, the first of which had indicated that this was the extent of the Sunnyside aquifer. So this is where it played out in the geological model. So to accommodate the updated interpretation, one of which included review of water levels and cross sections that extended beyond the model boundary, we came to the conclusion that there's likely potentially some flow in from the east, and we used the known water levels from observations to determine a flow across the boundary in these areas. Okay. The northern edge of the model boundary we're looking at now, and this thin blue line, it may not be very obvious on your monitors. I'll try and zoom in. You can see this is the Nickel-Mickle River edge of it. Okay. Go back to view. If we go to layer 5, which is the Sunnyside aquifer. Steady state height heads we have. as you go, the directions of the contour, you have inflowing in from the east, which was corresponds to those two blue areas that I described in the 3D view a moment ago. And the tends to go to west, some of it going out towards Boundary Bay and Mud Bay, and some of it going turning down south and going out to Semi-Amu Bay. And now if I put on the recharge distribution, we have homogeneous recharge distribution, which was originally set due to the predominantly urban land use in the area. The model is currently being tested for sensitivity and has been found to be fairly sensitive to spatial variability in recharge, and not entirely unexpected, given that we're modeling a confined aquifer, and that's where all of our calibrated data is. The in blue area is currently applied at 258 millimeters a year, which is taken from literature values. In this case, it's the Surrey Groundwater Supply Study Phase 1. The charge area along the Nickel River here has been applied due to the lower conductivity sediments that we've interpreted from our lithology here. I'll give you a fold back, Cedra, and then you could go back to the next slide. Let's go. Yeah, you take it back quicker. Yep. And I'll touch the water balance in a moment when the screen comes up.
There we go.
Okay. So I'm looking at the water balance. We can see that the inflows to the model consist of approximately 50% from precipitation and 50% from lateral inflows to the Sunnyside Aquifer. Majority of outflows to Semi-Amu and Boundary Bay, with small amounts flowing out to the rivers. Right.
Thank you. Next, we'll just present a bit of an overview on potential contaminants. This is generally just to review the sources that we are considering. We will complete a more detailed review of contaminant sources once we define the well capture zone. But general idea of what the data that we're considering. We looked at information from the site's registry, waste charge authorizations, existing and abandoned wells prior to 2005. So this date is chosen because general wells before they were not mandated to have a surface seal, just have a higher risk of vertical of contamination. We will also consider land use planning, major roads and transportation arteries, and also storm and sanitary sewers. This was the information from the site's registry available from the waste discharge authorization and wells that were constructed prior to 2005. And then the next shows the land use planning and transportation information we have. So this land use planning was compiled based on community planning from the City of Surrey and the City of White Rock. And categories were, I guess, generalized for us to provide, to merge the two, or the land use planning from the two municipalities. And the black lines and the dashed lines represent the major transportation routes that I'm considering.
So it's basically summarizes the level of the data that's been collected to try and put together a strong conceptual model for the region that can help inform the groundwater management tool, so that we can start delineating some capture zones to better understand the areas that we have to pay attention to management and define management strategies for those regions. So the steps, and what we'll be focused on in the subsequent webinar, will be the finalization of the future operational scenario. So we're looking or considering 4 development and future-looking scenarios. We're going to do a multi-criteria analysis based on financial, social, environmental, and regulatory context to try and what is the most viable option for meter demand. That scenario will be modeled, and we will then define some capture zones, and using the sensitivity analysis, we can define kind of like maximum and minimum capture zones and get a better sense of how sensitive the model is to that and what the total extent of the areas to be protected are. Also to be considered, because this is a coastal aquifer, there is a lot of question about the impact of climate change. And I mean, that can be an independent study in itself. So we're going to try and consider kind of the plausible worst scenario for groundwater supply and see what impact that has on the capture zones and the impact that may have on potential saltwater intrusion to the area. That's in our next phase of work. Capture zones and the analysis of change, we're also going to be looking then at identifying management measures for the city of White Rock, and that's going to be of an interesting discussion during the second webinar, as some of those management measures may tend to more regional discussions and ones that everyone as part of this technical working group may want to actively participate in. So we want to make sure there's an opportunity for a discussion about that and start that dialogue. We'll be drafting the plan and the input received from these technical working groups. That plan will be presented at a public open house that, as Jared said, is hoping to be scheduled early next year. The fund will be prepared as a result of feedback received from the public open house, and that plan will be presented to council early next year. These are kind of the next steps and what needs to happen. Lots of information that we could go into on all of these different things, and Zedra can talk for hours on data concerns with the water wells data and the difficulties of geology. But I'd like to open up in the last 15 minutes here for some questions or comments. If there's concern about the direction we're heading or considerations those on the phone would like us to take into account in the development of the plan. I will also note, and I meant to note it at the beginning, the conceptual model and understanding of water use was used from the draft master plan for the city of White Rock, and just recently that has been finalized, so that will be reviewed as well, just to make sure that we capture any updates. But is there other information that should be considered for the development of this conceptual model that maybe yourselves at the City of Surrey or the Ministry of Environment are aware of that you would like to bring to our attention that we haven't captured so far? Saved by phone call. Let's see here. Jeff, can I pick on you specifically to ask if you have any comments related to what you have seen so far?
No, excuse me, I don't have any specific comments. I appreciate you noting our interests in having groundwater as a potential source to supplement our use. So obviously we will have interests in the continuing that discussion kind of in the next round. But no specific comments or concerns raised anything that's been presented so far today.
I appreciate that. Mike, did you have any specific comments that you would like to draw to our attention or feedback?
I mean, it all looks really good. I guess the only thing that kind of comes to mind is, like you mentioned, there's lots of limitations with the wells database. I kind of know that, but where I was thinking was more the extraction values that you would use in the model. Just kind of curious how you put, rates to all these wells that may or may not exist. Kind of like, how did you come up with the numbers, and did you determine somehow whether or not the wells in the wells database are even still in use and what they're being used for?
Sure, yeah, it was. So as part of this, and we haven't, or using the wells database, we haven't verified any of that information, so we haven't conducted a survey to confirm that wells are in use and how much are being used. As with the Water Sustainability Act, we might get a better idea of the major users in, once that is better established and once that is better supported. But I think for the purposes of this plan, we've focused on, because we don't have any major users in the area via White Rock well, then I guess our focus is not necessarily on getting an accurate picture of the water balance, but more so identifying the well capture zones. So I think getting a clear picture of water use and making a better estimate of the water balance under these extraction scenarios, that would likely be for a different phase of the project.
That makes sense to me. I ask almost selfishly because with the licensing, field that I work in now, it's always kind of trying to get my hands on data that's been compiled on actual use. So really see how, using a model to develop capture zones, those are wells really may not matter. So that makes sense to me.
Yeah, just went back to this water user figure just to also show the location of a lot of the users in comparison to the White Rock wells. And it will depend on where these initial capture zones come up. If we have capture zones that are, circling some of these, I anticipate we will see that, but if we get capture zones that are circulating these waters here, it may be a question of looking at what we know about the water users and if we want to start considering them in the model themselves. Irrigation may be a higher use in drier times of years, and we've talked about how we would consider using that information, but none of the irrigation wells seem to be upstream from our water wells, and we don't think it's going to have a large impact at this stage in the project.
Okay.
Fortunately, that is a much different situation.
For White Rock, we have the SCADA data, and that was supplied. For 108, that just started, in fact, we have the details about the well and the structure and all that information available. Well number 4 has been upgraded and is getting connected to the SCADA now. So it used to be manually operated, no flow meter, and that has been updated now, upgraded with all the details. To make it, how can I say, technically sound as much as we can, and the other issue we have here, as you indicated, the location of the flow, and there is something also the aquifer protection need to look into as well, where future possible use at which section has a water quality compared to the other. I think water quality need to be included in this study as well, because seen on the east side, the water is likely not as good as the on the west side. Wells 6 and 7 has higher arsenic and manganese and ammonia compared to the wells 1, 2, 3, and 8. Well number 4 has slightly more iron, but that is useful in the application for the removal of arsenic as well.
Mm-hmm. I would say that we, at this stage, we're limited in the data that we have to spatially understand water quality links. Right, you can see that there seems to be a link to arsenic concerns with depth, and it would be great to have water quality data in these wells over here, but we need that at this time to know if it's whether the arsenic concerns are an eastern issue or a depth-related issue.
I think the discussion of water quality, when we're developing the conceptual model, we're looking at the physical aspects or water levels and stratigraphy, but it's also important to take water quality and, so multiple lines of evidence for development of our conceptual site model. So definitely, it's an important aspect of that.
To look also into the seasonal impacts as well. We've seen some changes in water quality and seasonal impact with the temperature and also the demand has impact on the water quality as well.
Mm-hmm. I was asked, Mark, you're also present on this call. Do you have a comment or feedback that you'd like to provide at this time for commission and move forward?
No, I think you guys are on the right track. It seems very reasonable what your approach is. From my point of view, it's just always certainly water quality is a big issue, but I appreciate the fact that historical water quality data is kind of hard to come by. There's a lot of data from South Group about water quality, particularly those wells, and that's certainly good to sort of see any trends and seasonally and why some of the levels of arsenic are changing, whether it's because of the amount that's been pumped or just different recharge considerations in that. I'm not sure. And no, I think everything looks pretty good here. What I would hope to see also is that when you're in your sense of contaminant inventories and that you would certainly include with your directions of groundwater flows and all that, time of travel, potential contaminant events that might occur, and that this public open house may out well for as part of the city's public education strategy, that certainly people will become aware of what's going on and call us and invest a lot. What White Rock should be doing in that. I don't know, there's been in previous protection plans, there's discussions about setting up a community groundwater protection committee. I don't know if that's going to be even considered here, but I don't know how effective those are. And signages and stuff like that, what the next stages are for public notifications about anything that goes on within the aquifer. But no, I'm impressed and encouraged by the work that you guys have done so far. It looks promising here.
Thank you. I appreciate that comment, Mark. And yeah, the notifications and travel times and that kind of information will be discussed in the Aquifer Protection Plan, specifically when we're looking at the capture zones, and it's within those areas where we need to define groundwater protected areas where signage and things like that are going to be a likely recommendation. I mean, obviously, that's to be discussed with City of White Rock, but we can see it happening. And see in discussions that we've had with that at the beginning of the project that hopefully moving forward, this technical working group helps to continue dialogue between the representatives here and the City of White Rock for the overall management of this aquifer. And we're encouraged by the participation today, and that that kind of step's been initiated. So thanks for your participation. We have, Sad, do you have anything else you'd like to add?
We have a very good start here, and we look forward for the next steps, and we have some additional participation, maybe First Nations and others, but I'm glad now with the good participation at this level now.
Okay. Thanks, Sad. So I'm amazed we're actually going to be able to finish up on time. I'm concerned about that with the level of information we're trying to go through, so thanks again for everyone's time. I recognize it's hard to fit all these conversations in sometimes, so I appreciate that you made the time for it, and we will send notification out for the second webinar when we confirm the time with City White Rock, and it'll be a similar venue like this so that it's easier for people to attend. It will also be recorded so that it can be published to the City of White Rock website. Thanks, everybody.
Thank you.